Hello, Andy. Here's your engine. All I got to do is change the or get the inner valve spring put back in on this, because there you break the camshaft in with only the outer valve spring on it. But it seems to run fine. Carburetor's not all set up for it because we're not going to be running this carburetor on it. But other than that, everything's cool. So let's just fire it up, and you can hear it run. No leaks, no drips, and there's quite a chop from that camshaft. You're going to be making a little bit of torque and horsepower of this engine. But I can't rev it up higher, Andy, because I say I don't have the valve springs in there yet to match the camshaft. That should whet your appetite. Anyways, talk later. Good day. Thanks for watching. It's been a number of months since I've posted any videos on YouTube on either channel, because I've been going through some health issues here that unfortunately still haven't been resolved, and the time I have had I've spent building customer engines. So one thing I do want to point out, I'm going to be making some changes to my YouTube videos, the channels. The one with T.J. Muzak, or Tim Muzak, that I'm only going to be posting engines that are for sale. All the technical videos will be going to Metal Max Mopar on YouTube, and if you're interested in swapping subscriptions to that, well, I'd appreciate it. And if you don't, well, I understand. Anyways, this is what I wanted to point out, this change. And then hopefully as my health improves again, I'll be able to start making videos, dealing with specialty builds and etc., etc. This one here is a Stroker 360 that's built for a customer, and basically I broke in the camshaft and it all went well. And for all those out there, it's a hydraulic flat tappet, and a pretty aggressive one from Hughes. And I used the Johnson High Lift variable duration lifters with it, and no problems whatsoever. 5W30 mineral oil with the Lucas additive. So, say what you want about it. Anyways, the right now I'm just doing the changeover for valve springs because the this camshaft's aggressive enough that you have to run a high tension, high load valve, dual valve spring, and I just broke it in with the singles that were on the Edelbrock heads for a flat tappet. Anyways, that's what you can see happening here. So. One thing I do want to point out for those that are just getting into this, that pattern there, hopefully it'll focus, that's what you get when you spend time setting up the geometry of the valve train. You get a nice perfect sweep in the center of the valve stem, and every one of these valves has it. A nice clean sweep right through the center of the valve stem. And that's exactly what you want. You want no side loading. And it's a time-consuming process because you have to measure, remeasure, shim the shaft sometimes. And like I say, you'll have to play around, just get the exact right push rod length to get this. So just something I say to point out to some of the not more novice engine builders, it's worthwhile taking the time to set up the valve train and not just bolt on the components and assume that what you've got is correct. And these are with the Hughes roller rockers. And say what you would do, you typically just get a felt, either machinist die or a felt pen, mark it, and it just rotate through. And unfortunately, you're going to have to do it to all of them. You can't just do it to one set and expect them to be the same on all 16 valves. So anyways, that's what's going on right here, is just like to say the valve spring changeover. I built my own tool to do this. I say I don't believe in spending a lot of money on garbage tools that are out there, and I mean, just like garbage parts, there's a lot of garbage tools. So this thing I've built works fine. And same with the little air hose compressor. Built those too out of just spark plugs. Knock the porcelain out, weld the air hose fitting on it, screw it in, and away you go. Anyways, I just wanted to catch up with some of you viewers on what's sort of happening here, and I will get back, like I say, to with the Metal Max Mopar channel, more on the technical and the building side for future engine builds. And we'll go from there. Anyways, thanks for watching, and we'll see you later. Yeah, hi, I want to elaborate here based on what I said the last time about valve train geometry and setting this up. This side here looks like it's got a little better pattern. I think that'll show up on the camera somewhat better for the roller tip pattern in the center of the valve. And setting up rocker arm geometry. And why this is important. If these patterns are off to the high side or off to the low side, that can exacerbate wear on the guide. So the guides end up wearing their bell, they end up bell mouthing, top and bottom. Especially when you start getting into the higher spring pressures, you can really exacerbate guide wear. The other thing about checking valve chain geometry, and I'll show you what the cam is I'm using on this particular engine. This is a Hughes grind, 3642 AL-08. 546 on the intake at 236 duration 050. 563 242 duration on the exhaust at 050. And the reason I go with this cam, I've used this cam numerous times on stroker builds. And basically any engine I'm using a stock Edelbrock head, because the stock Edelbrocks, the RPMs don't flow any better above 550 lift. So we're right in the sweet spot at these particular numbers, at lift numbers, with a stock Edelbrock head. You want them to flow better, you got to get into porting. So this is why I choose this particular grind, or grinds very similar to it in a roller or from other manufacturers. So there's some method to the madness I'm choosing here. The other thought, I get guys approaching me about building engines. They want me to use Edelbrock or an aftermarket aluminum head, but they don't want to spend the money on rocker arms. They still want to use these things. Now, these have no business being on a high-performance engine. Stock stamped steel rocker arms range in ratio from as high as, say, 1.47 to as low as 1.35 when you measure them. And you can measure them. It's not hard to measure them. I have a tool around here somewhere, but I'll just give you a brief example. You know, mount the shaft, cut a shaft down, mount the shaft on something, weld it or bolt it, whatever you want to do. Load a spring with a stop under one end and put a dial indicator under the other end and push up on it. Put a stop on it and measure the difference. Measure the height difference from one side. When you push down on this side, what's the height side from this one? And then you can see whether you're getting a true 1.5 ratio or a 1.4 ratio or whatever the hell the ratio happens to be. And if you just look at the patterns on the tips of some of these stock rockers, you can tell they're all over the place. So bolting a set of these onto on a set of high-performance aftermarket heads is just a waste of time. Why bother buying the head? You have no idea what the lift's going to be. Right? You didn't check it. So you have, well, geez, is it going to be the full, you know, what I'm paying for with the camshaft? Is it going to be a full 563 on the exhaust and a full 546 on the intake? Or is it going to be 530, 520? You know, whatever the number happens to be based on your rocker arm ratio. This is why it's important to check. Right? Anybody that tells you different, well, they're full of shit. And there's a lot of guys out there full of shit because they don't want to take the time or they can't think. Sorry to be so blunt about it, but that's just the facts. So if you're going to go to an aftermarket head, seriously consider getting aftermarket rockers. And that goes for the Chevrolet and the Ford guys too. Any of these stamped steel guys, they're all over the place. And like I said, the only reason to use them is if you're running, say, a stock car class or NHRA stock eliminator where the rules require you to use them. Well, then get a whole bunch of them from your parts store, make a jig up and start measuring them to see how close you can get to 1.5 for all 16 rockers. Because that's the only way you're going to make true power based on the rules. If not, you're just guessing. You have no idea. And I say, no one says you have to spend, you know, big money like you do on, you know, these Hughes. There's other ones out there. I mean, the cheap Chinese aluminum ones I'm a little leery of, but the stainless steel ones, I've used them and I've got faith in them. I've had no trouble with a lot of the stainless steel Chinese aftermarket ones. You know, they're a little heavier, but like I say, and the ratios seem to be pretty much bang on. Anytime I've measured them, they're 1.5 or 1.6 if I decide to buy them. So anyway, it's just something I wanted to add. You know, when you're building high performance engines, if you're just building a stock engine for a stock rebuild and you're not really after, you just want a little upgrade to cam, then it doesn't matter. You're not going to end up spending the money, you know, upgrading, you know, the valve train and doing all this extra work to find out what your rocker arm ratios are. You're just looking for a little more oomph, and that's all you'll get, just a little more oomph. But this is what separates, you know, a serious build from a so-so build, from a clueless build. Anyways, I just wanted to add that in, and why it was important. And I say it is time consuming, and it takes a lot of time, especially on the Mopars when you got to start shimming the shafts and playing around with different rocker arm lengths, and you know, it can eat up a lot of time. But the results are a lot more horsepower and a lot more torque. Anyways, that's what I wanted to leave you with. Thanks for listening. Bye now.